welcome. Thank you all for joining today's IAQM webinar, which is Fossil Fuels and VOC Air Pollution from Oil Well to Kitchen Counter. Today, as you can see, we're joined by Dr Aidan Farrow, who works within Greenpeace's International Science Unit. After graduating from Edinburgh and Bristol universities, Aidan moved to the University of Hertfordshire to begin working in the field of air quality as a postdoctoral researcher. After some time working as a consultant, Aidan joined the Greenpeace research laboratories at the University of Exeter in 2018. His work with Greenpeace investigates atmospheric pollution, its causes, and health impacts. Today's webinar, as I'm sure you know, will present the results of field studies which investigated ambient VOC concentrations and potential routes to exposure within oil fields in Iraq, Nigeria, and the UK. There will also be discussion around the investigative work carried out within the environmental NGO sector and the importance of evidence-based campaigning. As always, there will be questions at the end of the presentation, so please feel free to submit these in the Q&A function at the bottom of your screen throughout the presentation. I'll keep an eye on this and ask them on your behalf when Aidan's finished presenting. So thank you all for joining. I will now hand over to Aidan.
Thanks for having me and for the introduction. It's a real pleasure to speak to this community today. And as you've just heard, I'm going to be talking today about some work that I've been involved in with Greenpeace over the last 4 years or so, looking at volatile organic compounds and air pollution and their links to both oil and gas production, but also where we use those fuels in our homes and where we're exposed to them away from those industrial sites as well. To start off with a little introduction to our team and where we work. So lots of people will have come across Greenpeace before, perhaps because we have a fleet of ships that do campaigns and try to grab headlines around the world. So we've got images here that show the Rainbow Warrior and the Arctic sunrise. Another image there showing some Greenpeace campaigners hanging from an oil drilling platform. I think that one is in Norway. And these are things that Greenpeace are quite well known for, these confrontational campaigning moments. What's a little bit less well known is both of our ships almost always have scientists on board working, and all of Greenpeace's campaigns are built on a foundation of scientific work. And a lot of that comes through the team that I work in at the Greenpeace Research Labs. We're based at the University of Exeter. You can see an image there of one of our analytical labs, and it's set up to run all kinds of environmental screening analyses, essentially forensic science, but for environmental problems. My team and the work that I do covers a really broad range of different air pollution topics. Within the huge organization that is Greenpeace, we have one air quality scientist. So I cover a wide range of things, ranging from designing field campaigns and going to make measurements. Because we're relatively understaffed, we prioritize. So we try to take air pollution measurements of pollutants that other people aren't looking at in places where there is no existing data, and in places where there are communities that can be empowered by getting some data. So that often means that I'm not working in the UK, I'm working overseas. We use modeling to work on a lot of these problems, especially where there's no chance of generating measurement data. A lot of that revolves around looking at health costs and working back to pollution sources. And we also try to make the most out of data analysis. So there's images here showing the Tropomi instrument on the Sentinel satellite, which I'm sure many people are really familiar with, and a map produced by one of my colleagues earlier this year, which looked at NO2 columns across Africa and how they correlate to major pollution sources. So if you can see that the small dots on the maps are coal power plants and coal mines, and the orange shading shows that parts of South Africa have some really, really high elevations of NO2 that you can observe from space. All of this work is really important to Greenpeace because it produces a foundation for thinking about what future policy should be like and campaigning for cleaner, fairer, greener environments for people to live in. So this is the context in which I work. And today I'm going to talk a little bit about some specific projects looking at oil and gas pollution and where we're exposed to them, both in the production sites and at home. So oil and gas production is associated with lots of health relevant air pollutants, whether that's from the vehicles that visit the sites, the equipment on the sites, leaks, deliberate vents of gases, or burning and flaring gases. And flaring will be one particular focus today. I'm going to look a little bit at Iraq and Nigeria, where we've done some field work. These are two countries that are among the world's top 10 in terms of the volume of gas that is flared in those countries. And they're also interesting because they're places where there are local communities living very, very close to the oil and gas industry sites. Some work published late last year by Clean Air Task Force highlighted that in Iraq and Nigeria, 3 million in Iraq and 2.5 million people in Nigeria live within 5 kilometers of sites that are regularly flaring oil and gas. They're both countries where there is a severe lack in air quality data or any environmental data. So although you can often see potential sources of pollution, there's very little evidence to see how severe the problems actually are. As I just mentioned, there are large populations in these places, but they're populations close to the industrial settings. And they're places where products are being produced that end up in our homes, and there are exposure to some of those chemicals, not just where they're being produced, but internationally in the UK, in our kitchens, for example, if we're using gas. So I'll talk a little bit about that today too. The work started when we were approached by the BBC. They showed us these images. They said, we've been working with a community in Iraq, and in Iraq, there are some of the world's largest oil fields, and the oil fields are set up to collect oil, but not for gas. So the consequence of that is the gas is often simply burned, flared, or released. And you can look on satellite images and see farms and homes that are really, really close to these heavily active flaring sites. They were also working with Ali and Fatima, who are pictured here, who are both young people living near the Rumaila oil field in Iraq, who were also being treated for leukemia at the time that the investigation was being undertaken. And the question that the BBC asked us was, is there a link between what we can see in these oil fields and some of the health impacts that local people think could be related to the oil industry? And we looked at the images the BBC provided us, and you can see these are two screenshots that show some typical examples of the flares in southern Iraq. They're burning large amounts of fuel. They're not particularly burning cleanly. There's thick black smoke. And we thought, how can we gather some evidence and investigate what is the problem here? Is there a real health risk from these sites? How can we help the BBC gather some useful data as part of their investigation? And in those plumes of smoke that you just saw, there's obviously going to be CO2 and nitrogen oxides. There's products of the fuel being burned. There's almost certainly methane, which is not being burnt as the combustion won't be complete. There'll probably be carbon monoxide. We can see the particles and the black carbon, which we know are hazardous to health. Some of the oil fields there have lots of sulfur, so there's probably H2S and SO2 problems. And it's really likely that there are going to be some volatile component in the pollution plumes there as well. The challenge was going to these places and taking robust and reliable measurements. Measuring nitrogen dioxide and some of these gases is extremely challenging, especially in a place where you don't have access to calibration equipment and there's no reference grade monitoring available. Measuring particulate matter can easily be done these days with nice low-cost sensors. We could certainly have done that, but it's a semi-desert environment. There's so much dust there already. We were concerned it might be hard to identify good signals from particular sources. So that left us looking at the volatile components of the plumes from those flares. And we were particularly interested in looking at compounds like benzene, which have known carcinogenic and human health impacts. Another challenge of working on the topic of flaring is no two flares are the same. They depend, what is emitted from each flare depends on the composition of the gas that's being flared, the design of the flare, how tall the stack is, what the combustion efficiency is, and the amount or the risk of exposure relates to how much gas is being flared and when it's being flared and those sorts of things. We collaborated with a team from AriaNet, who are an Italian research group, who looked into the possibility of modeling some of the flares in southern Iraq, which they went on to do. And I just wanted to share quickly this table from their work, which shows the huge range in different estimates of emissions from flare sites. So you can see here a large number of studies from relatively recent years that tried to estimate emissions factors for different types of flares. And if we look at the second column, which is for the VOC component, we can see that estimates range from as low as 1.5 grams per kilogram of gas flared through to 12.3. So there's a huge uncertainty in the amount of pollution that's generated from these different types of flare situations. Before I move on and talk more about what we did during our research, I thought I'd put one particular compound in a bit of context. So benzene is going to be a focus of the talk. And in the UK, benzene is regulated. In England and Wales, and also through our obligations to Europe, there's an objective of 5 micrograms per meter cubed as an annual average. In Scotland and Northern Ireland, it's a little bit lower. And if we look at some of the sites that monitor benzene in the UK, there's an automatic monitor at Marylebone Road, which is I think of the 4 or 5 across the UK that regular automatic monitors that look at benzene. This one records the highest concentrations, and its annual average in both 2022 and 2023 was around 0.6 micrograms per meter cubed. The UK also has a non-automatic network that looks at roughly 2-week averages using passive samplers. And the highest recorded 2-week sample across the UK last year was around 2.4 micrograms per meter cubed. So those are some numbers to have in mind as we look through the results that we got from our field studies in Iraq and Nigeria. We used a similar approach, taking 2-week samples in our Iraq work. And it's also just worth pointing out here that at Marylebone Road, the bottom plot here shows the 2-week averages for the last 2 years. And it's never been above about 1.5 micrograms per meter cubed over that 2-week averaging period. So I mentioned before that working in Iraq is challenging. We don't have reference instruments, we don't have ways to calibrate equipment, but we wanted to go and investigate these VOCs in the communities that the BBC were working in. The map on the right here shows the city of Basra and some of the surrounding towns. The orange dots are locations where there are flares. These were identified using a satellite dataset. And the pale blue dots show sampling locations that we worked with. A local researcher called Shukri Al-Hassan from the university there helped us to deploy thermal desorption tubes, which work in a similar way to lots of other passive sampling devices. You leave them in situ for 2 weeks in our case, the VOCs in the air are absorbed onto the matrix inside the sampling tubes. They can be sealed and then sent back to our labs in Exeter at the university, where we use a gas chromatograph mass spectrometer to find the amount of VOCs stored on each tube and then work back from there to estimate the concentrations that were in the air during our study period. And what we found was relatively strong evidence that benzene levels were higher in sites which were closer to flares, but with our quite small data set, we can't be extremely confident about that. What we also found was that those 2-week diffusive samples, the vast majority of the samples that we returned were higher than we find in central London at the Marylebone site, were higher than any 2-week passive sample produced by our monitoring networks across the UK. So highlighted in red in this table here shows that the vast majority of our snapshot of data from Iraq was higher than you would expect to find anywhere in the UK, despite the fact that these are relatively rural locations that we were working in. And I think this is reasonably strong evidence that there was an important source of VOCs in southern Iraq. It seems very likely that the oil industry is part of that, but we can't rule out other sources like different cooking techniques or traffic and these sorts of things. This project with the BBC was then produced into a documentary, and I'll share details of that later, and you're welcome to take a look at it. But it sparked an interest within our team about where else are there similar situations where local populations are exposed to pollutants from the production of oil and gas. And to put this into a little bit of context here, globally, the amount of gas being flared has increased in the last year, and we're now back at levels not seen since before the pandemic. So unfortunately, it's currently a growing problem. In the UK, flare volumes have fallen or remained roughly the same, but flaring intensity, so the amount of flaring per barrel of oil produced, has been falling. So things in some senses have been improving in the UK. This is not the case everywhere. So in Nigeria, although oil production is falling, flaring intensity is not. So there's not any action to reduce the amount of fuel or gas that's being flared per barrel of oil that's being produced. The countries that are worst for flaring, or that flare the most, are Russia, Iran, Iraq, the USA, Venezuela, Algeria, Libya, and Nigeria and Mexico. And evidence suggests that globally flaring emissions lead to around 500,000 dailies. So that's a way of measuring lives lost and years lived with disability as a consequence of being exposed to these air pollutants. It's a really important issue also because amongst all of this gas that's being burned, methane is being released unburned, which is a potent greenhouse gas and critical to climate objectives. These are the 3 case studies that we've looked at so far. I've shown you a little bit of the work we've done in southern Iraq. That's the map in the center. You can see the flare locations shown in orange, and those vertical north-south stripes show the positions of different oil fields. The left-hand panel shows southeast England. Each map is the same surface area, so the scale is the same on each map. There are a few flaring sites in southeast England. And the Niger Delta area there is put in context as well. You can see that there are a very, very large number of flaring sites. So because we had some data from southern Iraq, we have the opportunity to work in southern England, and because the Niger Delta has this really extensive network of flares, we chose to investigate further in Nigeria. There is very little environmental data in Nigeria. some estimates about the air quality impacts recently have been that air quality leads to reducing life expectancy by about 1.5 years for Nigerians, that there's a large disease burden from air pollution, including fossil fuel specific air pollution. Global emissions inventories suggest that in West Africa, the energy sector is responsible for most volatile organic compound emissions. And it's also a country where there was rapid growth in the oil industry in the 60s and 70s, but very little development for dealing with gas rather than oil. And that means that lots of the oil industry facilities simply release or burn the gas they produce as a byproduct of producing oil, although some gas is now being used for electricity generation. The map on the right here shows non-methane volatile organic compound emissions for different African countries, and you can see that Nigeria stands out as being a high emitter. We tried to find some sites in Nigeria where there was a high risk of exposure to these sorts of pollutants. The map here shows the blue dots, which are flare sites. The size of the dot shows the volume of gas being flared each year, and the green shading shows population density. And we combined those two to try and identify flaring sites where there was both a large population nearby and a large amount of gas being burned each year, and chose 3 sites to investigate in more detail. Agbada, which is near the city of Port Harcourt, and then 2 sites, Obiafu and Ukheli, which are in smaller communities in the north of the Delta. We worked with the University of Port Harcourt and a researcher called Labari Sibe to take samples of VOCs using a pump at these flaring sites. Work in Nigeria is extremely difficult. There are militia and very dangerous situations when you're trying to do investigative work in these places. So we weren't able to take longer period samples, 2-week samples, or to revisit sites. It was a case of taking samples and leaving quite quickly. And what we found was, again, concentrations of benzene that are considerably higher than we might expect to find in the UK, albeit we only have very small grab samples of air. And we found that at locations where there were really heavy oil industry presence, we got the highest concentrations, with one exception, and that was in a town in the Agbada region where the highest benzene level we found was actually in an urban area where there are diesel generators, there are barbecues, there's traffic as well. So our preliminary conclusions are that there's likely to be a big oil industry source for these volatile compounds, but that there are a large number of other sources nearby as well. I just quickly want to mention at this point that our methods for sampling were partly developed in a collaboration with the University of the West of England as well, and Jackie Warner, who I think might be joining us in the call today. So thank you to her for her efforts developing our methods. The results we got from Nigeria, as I just mentioned, showed some quite high levels of some of the VOCs that we looked for. The highest benzene measurement over 22 micrograms per meter cubed. As a snapshot, this doesn't tell us a huge amount of information, but it tells us that there is likely to be a considerable or non-negligible exposure risk to the communities that we visited. I'm going to bring things back to the UK now before I start to wrap up. And you'll have seen in one of my earlier plots, there are some oil wells and flaring sites in southern England. Earlier this year, I visited the Singleton oil well with a team from Clean Air Task Force, who are another NGO working on methane and volatile organic compound emissions. They used a optical gas imaging camera to identify that methane was simply being released into the atmosphere from their vents, as well as burned in their flares. They also identified a leak from some pipes, which seemed to be completely unintentional. at that site as well. So although this site is not close to any populated places, it's a couple of kilometers to the nearest houses. I think it's interesting to note that even here in the UK, there are places where the oil industry and oil extraction is leading to non-negligible emissions of these health-relevant air pollutants. Finally, before I conclude, I want to bring this even closer to home and think about where the fuels go once they've been produced. There is a group called PSE who are working in the United States mostly, who've been looking at which hazardous air pollutants are still in gas that is piped to our homes. It's not burnt when it's produced. We use it as a fuel. And they found visiting houses in Boston and in California that gas combustion and leakage from our cookers in our kitchens leads to hazardous air pollutants in our homes. So over 99% of the samples they collected contained hazardous air pollutants, and 97% of them contained benzene, the cancer-causing chemical I mentioned earlier. And I think quite an interesting finding from their work is that even when hobs are turned off, they can leak gas into your kitchen, and that you can have a health-relevant level of some of these compounds below the threshold at which the odorant in the gas could be detected. And they summarize this nicely by saying that home is where the pipeline ends, and that some of the oil industry problems that we've been investigating overseas come directly back to places that we're living as well. This is going to be a focus of our work going forward. We're currently putting together a project to do further sampling in Europe, in kitchens, seeing if we can replicate the results that these folks have had overseas in the United States. So by way of conclusion, over the last few years, Greenpeace has been working with a variety of different experts to make volatile organic compound measurements in communities where we're concerned there's a risk of exposure, particularly relating to the production of oil and gas. We haven't so far said the oil and gas industry is the only source of these pollutants. There are many, many others which could be contributing to the concentrations that we've measured. We've looked at satellite data of where flaring is occurring and where these production sites are, and how large populations are living very close to them. And I think we found useful evidence that says that there is a risk for exposure at some of these oil and gas production sites. And our next steps are to look at whether there's a similar risk in domestic settings in Europe as well. If you're interested to see a little bit more about the work we did in Iraq, you've just seen a video clip from the BBC's documentary that looked into this issue. That's available to watch. I think it's still on iPlayer. It's certainly available on the BBC World Service's YouTube channel. And you might also be interested to know that some of the data is being used actively to campaign to improve the situation in Iraq. The father of Ali, who I mentioned earlier, is taking a legal action against BP, who operates some of the flares that I mentioned. And he's actually had the opportunity to speak directly to BP at their annual general meeting as well. So that's one way that this scientific work has given a platform to an affected individual to ask questions of the polluters in this case. Before I finish, I just want to say thank you to a few contributors, particularly Joe from Unearthed at Greenpeace UK, Sandro and Paola from AreaNet, Labari from the University of Port Harcourt in Nigeria, Jackie from University of West England, Theo from Clean Air Task Force, Shukri, Ali, Owen Pinnell, and Jess Kelly, who all worked on the work in Iraq with the BBC. And finally, BBC Arabic Investigations, who made that first investigation possible. Thank you very much.
Thanks, Aidan. That was really interesting. and I can see there's already some questions coming in. Just to give people kind of a chance to collect their thoughts and type up any questions that they've got, I'd be really interested. Obviously, you mentioned the range of challenges that come up when you're actually collecting the data, but I'd be interested to know how that affects the reporting of your findings in terms of communicating with affected communities and decision makers. Are there any kind of related challenges that come up?
There definitely are. One of the big differences between work that I've done, and I know many of you in the audience have done in the UK, is in Iraq and Nigeria, it's difficult to publish exactly where you took your sample in case the homeowner that allowed you to install your monitor is threatened or put under pressure as a consequence of that. So there are really quite unusual challenges in terms of going to these places, taking measurements, and not bringing an additional risk to the people that you're trying to support and help. And that was quite the first time I came across that was working in Iraq, and I don't think the project would have gone ahead had we not had the BBC as a partner who were able to advise on how you take care of the participants in your study and make sure that you're doing something which is both scientifically robust but not bringing additional risk to the people who are already facing these problems.
Thank you. Yeah, that sounds like a really tricky balance to strike. So yeah, we have some questions from the chat. First of all, the oil and gas industry in the UK is highly regulated. Were you able to find any useful data for comparison to Iraq and Nigeria in terms of flaring, venting, or air pollutant measurements in close proximity to these sites?
Yeah, that's a good question. The lack of data in Nigeria and Iraq is one of the really biggest problems. And when we looked at the published literature for emission rates, it became really, really clear that they were so variable between different places. It's very, very hard to make to take learnings that you have from the USA or Europe, where perhaps flares have been investigated and emission rates have been well understood, and apply them elsewhere. So it's quite hard to take out learnings from the better regulated situations we're perhaps used to in the UK and then apply them elsewhere, because the lack of regulation means the processes are so different. So that's a really hard thing to do. It's a useful thing to do from a campaigning perspective, because you can say confidently that things could be improved. If you can compare one regulatory system to another and say this flare design could be improved, that's actually a very powerful and useful thing to be able to say.
Thank you. So next, in a European domestic setting, is there any data to determine the percentage contribution of VOCs from gas usage compared to other residential sources?
I think there is. Certainly in the UK, we've got nice inventories for most of these pollutants. I think there are some questions being raised about some of the assumptions behind those and what the emissions factors are and whether they are needing to be updated. And also, no, I mentioned the work from PSE, who the American researchers, they have recently done a measurement campaign in the UK and Italy, and I'm really looking forward to their results and to see how their estimates of emissions in those domestic settings compare to the emissions factors that we are currently using in things like the NAEI. So yes, there's definitely some data there. I think it's really useful, and it's going to be really interesting to see how some of this new research compares and whether our emissions factors are really robust or not. Yeah.
Thanks. And then going back to the case study about Iraq, someone was interested in hearing a bit more about the passive sampling methods that you used to collect that data.
Yeah, so I went over that really quickly. We broadly follow a methodology that's recommended by the United States Environmental Protection Agency. It uses thermal desorption tubes, which are these small steel tubes, if you're not familiar with them, about the size of a pen or a pencil. They have an inert coating on the outside and seals at each end, and inside is activated charcoal or graphite matrix. VOCs in the atmosphere will absorb onto those onto the carbon inside the tubes. You can seal them up and bring them back to a laboratory, and they can be thermally desorbed. So we heat them up, release the VOCs that have been trapped there, and then pass them into our gas chromatograph mass spectrometer to measure them. It's we can deploy the method two ways, either as we did in Iraq as passive sampling, using a 2-week sampling window, or you can use a pump to draw air through the sample tube, and which is in some ways an advantageous method because you know exactly the volume of air you've sampled. In other ways, it's a more difficult method because you end up with data just for that very short window of time when your pump was operating. In some ways, our Iraq study, which used those 2-week averages, we actually had 2 separate field campaigns, summer and winter, gave us more confidence about the big picture of exposure. And our Nigeria work was a little bit compromised because we were only able to take the pumped samples, which are really, really short windows of time, and just give you a slither of information about the environment. The big benefits for me are that the sampling equipment is low cost, and the expensive analytical equipment that stays in the UK isn't exposed to the risks of working in the field. So that makes it a really attractive methodology.
Obviously, you mentioned that there was a challenge in kind of collecting broader data, especially in Nigeria. But did you get the chance to compare the benzene levels in any regular households internationally, just as another point of comparison?
So this is one of our very next steps. We're currently developing a protocol for doing measurements indoors in kitchen environments. There are some challenges there because one of the things the thermal desorption tubes don't like is too much humidity. And if you're in a kitchen, that's often a very humid environment. So we've been working with some suppliers to make sure that we can take samples which are likely to capture benzene inside in those indoor environments. And we're hoping to start doing that in November. So I'll have to come back and present those results when we have them.
Absolutely, definitely. I guess also kind of thinking about next steps in the future of these findings. What are your thoughts on kind of being able to mitigate the pollution caused by flares from oil and gas industries? And yeah, what do you think can be done or might be done to address that problem?
There's lots of work being done on this. Earlier this year, the European Union moved to introduce an import standard for fossil fuels, which means that the flaring and methane intensity of the fuel that's being imported is now regulated. So it's disincentivizing European countries from buying these fossil fuels from places where flaring and venting of methane is a bigger problem. And I think that is one mechanism that's going to put pressure on oil and gas producers to try and improve their methods. The World Bank are currently working on their initiative to end routine flaring by 2030, which I think is another important initiative. The challenge there is defining what routine flaring is. I was talking to a journalist earlier today who was looking at Total, and he said that Total currently claim that only 10% of the gas they flare is routine. The remaining 90% is an emergency. So there's a challenge there in translating the intention of this zero routine flaring legislation into an actual meaningful reduction in the flaring. But I think gathering data that helps people who are worried about this from local communities can be an important catalyst to start discussion, to provide evidence that it's not okay to complete these activities without reporting on your environmental impacts, and that those sorts of mechanisms put pressure on companies to both operate in a more transparent way, do some environmental reporting, which is non-existent in many of these places, and ideally to start employing best available techniques to reduce their emissions.
Great, thanks, Aidan. I think just being mindful of time, that's probably all the questions we'll be able to get through for now. To everyone still here, Aidan has really kindly said that if you'd like to get in touch with him afterwards and follow up on anything or ask any questions you haven't had the chance to, then you're welcome to. So please do take advantage of that and pick his brains a bit more if you want to. But yeah, thank you again, Aidan, for presenting. It was a really interesting set of slides, and I think great in particular to hear about the next steps and where your findings are going to be able to go. That is it from us today, as I said. So everyone that's joined in, thank you for logging on and joining in this presentation with us. I hope you found it beneficial and informative. If you are an IES member, just a quick reminder to record your attendance. You can do this using the CPD tool, which is in the members area on the website. So if you're watching this on YouTube as a recording, please do subscribe and like the video. You can also click on the bell to be notified when we post something new. So thank you again for joining us, and thank you to Aidan in particular for a really great presentation. Hope you all have a lovely rest of your day.